Hey guys, today we are going to be looking at multiplying two polynomials. So there's essentially two methods in which we can do this. The first one we're going to call FOIL. It's old school and doesn't always work, but it does work when you're looking at binomials. Okay, it only works for certain types. The second way is a rectangular array, and it works no matter what type of polynomial you're given. And actually, method 2 is my favorite method because it works no matter what, so I don't have to reteach myself a new method to multiply other types of polynomials. When I say types, I'm talking about binomials, so the 2 by 2, the 2 by 2 times 2 by 2. Let's go ahead and get started with some examples. I'm going to practice all of these ones using the rectangular array, and then the next set I'm going to show you using FOIL. Okay, so this is a 1, 2 binomial, 1, 2 binomial. So I'm going to set up a 2 by 2 rectangular array. My first one, doesn't matter where you place them, okay, is y and 4. My second one is y and 1. And I'm just going to go through and multiply. Y times y is y squared. Y times 1 is y. Y times 4 is 4y. 4y. And 1 times 4 is 4. Now I'm just going to combine like terms as I grab out. And this says 4. Oh. This says 4. Okay, now I'm going to combine my like terms. Y squared. Here's my like terms. 4y plus y is 5y plus 4. Done. Again, we're going to do a rectangular array. It's a 2 by 2, so I'm going to have a 4 grid, z, -2, z, 6. Z times z is z squared, 6 times z is 6z, z times -2 is -2z, 6 times -2 is -12. Now I'm going to grab my like terms, and I'm going to combine them, and I'm going to order everything in standard form outside of my rectangular array. Z squared, 6z plus -2z is 4z minus 12. Done. All right, example 3. P plus 3, p minus 8, multiply them, p squared, -8p, 3p, 3 times 8 is 24, positive times negative is negative. Now combine your like terms and put in standard form, p squared, -8 plus 3p is -5p minus 24. Last but not least, r minus 5, 2r minus 1, 2r squared, -r, -10r, and 5. Combine your like terms and put in standard form, 2r squared minus 11r plus 5. Great, so that's the rectangular array. That's my preferred method just because it always works no matter if you're giving binomial times binomial. Let's go ahead and talk about the FOIL way. You can like the FOIL way, it's okay. It's just not going to help you next year or the year after if you're given more than a binomial, okay? So FOIL, F-O-I-L, first, outer, inner, last. First to first, m times m is m squared. Outer, 5 times 6, -6, sorry. 5 times -6, negative 30. Inner, 5 times m plus 5m. Last, 5 m times 6, -6, sorry. -6m. Combine your like terms, put into standard form, m squared. Here's your like terms right here. Put them into standard form. Minus m minus 30. There's FOIL's method. Again, first to first, x times x, x squared, outer to outer, negative 4 times 2 is negative 8, inner, negative 4 times x, negative 4x, last, x times 2 plus 2x. Combine your like terms and put into standard form. Like terms are right here. Not there, sorry. X squared, negative 4x plus 2x is a negative 2x minus 8. Done. Again, first to first, 6k squared first, oh, I'm supposed to do outer. K times 3, 3k, inner, 5 times 6k, 30k, last. 5 times 3, 15. Combine your like terms. Sorry, I accidentally flip-flopped these in this too over here. That's okay because we got the same thing. Now we combine our like terms, and actually this turned out nicer. 6k plus 33k plus 15. First to first, 2u squared, outer, 2u times negative 3 halves, which is negative 3u. Inner, 1/2 to u plus 1/2 u, and outer, 1/2 to negative 3 halves. This is 1 times 3 is 3, 2 times 2 is 4. Combine your like terms right here. 2u squared minus 2.5u minus 3/4. Now this is a little bit messy, so let's make this all fractions or decimals. So 2u squared minus 2.5u minus 0.75, or 2u squared minus 2 1/2 u minus 3/4. All of those would be okay. But these are all the simplified ones. These ones are the nicer ones. All right. Here's where we run into trouble, I'm telling you, because we have a binomial times a trinomial, and this is when we have to use a rectangular array where we have x times 1, x plus 1 times x squared times 5x times 8. X times x squared is x cubed. Just add 1 to the exponent. X times 5x is 5x squared. 8 times x, it is 8x. X squared times 1 is x squared. 5x times 1 is 5x. And 8 times 1 is 8. Now we're going to go through and combine our like terms. So these two are like terms because they have the same exponent. These two are like terms because they have the same exponent. X cubed plus 6x squared plus 5 plus 8, 13x plus 8. Standard form, combined like terms, no parentheses. All the exponents are together. Great. Again, here we have a trinomial times a binomial. We'll have to use a rectangular array. And minus 3, n squared, negative 2, and 4, n cubed, those two multiplied. These two multiplied, negative 2n squared, n times n is n squared, 4n. N squared times negative 3 is negative 3n squared. Negative 2n times negative 3 is positive 6n. and negative 3 times 4 is negative 12. Like terms right here and like here. So we're going to combine them and we're going to put into standard form. N cubed minus 5n squared plus 10n minus 12. Done, done. Have to use a rectangular array. There is no FOIL method for this one. All right, here's your on your own problems. Please pause your video at this point. Thank you for pausing your video. Here's what you should have gotten after you did all that work and you had to use a rectangular array for number 5. Go ahead and answer this essential question. Essentially, you're going to say if you like the FOIL or if you like the rectangular array. It's up to you. Just make sure you know how to do it properly. I'll see you guys tomorrow. Good luck on that checkpoint. I hope you're having a great night. Stay warm. Bye, guys.